the agenda that I'm planned for this IoT, especially with IoT. I still remember a good few years ago. So when I used to be in my engineering, I would just mention IoT in whatever answers for whatever examples I could find. I would just mention those answers. So it was a fancy term back then. Right now, I have come a long way and technology has come a long way. So I just thought I would like to share more about what I've learned through it. And so in this agenda, these are the topics I would like to cover. So first thing, we will be talking about IoT and its definitions. We will also talk about a little bit of history of how IoT evolved over the period of time. And second thing is about why do we need IoT? So in this case, we could talk some benefits about IoT, and we could see how small industries are adapting to IoT, and how big industries are adapting IoT, and why now suddenly all of industries want to change or transform their technology towards IoT. We could speak about that, and in current trends, we could discuss few keywords about trends that's increasing and the trends that is going down, those kind of things, and the state of art and working topic. We could again I would like to talk about features. So we talk about what IoT is moving towards, and a list of characteristics and things that we would like to keep in mind. So we would also go much in detail about the hardware and software development as well. So we would also cover a little bit of design of the system, and from the case study I have jotted down few case studies from different industries. It's not necessarily the best IoT case studies, but I've try to prove a point of how IoT is used across different industries. So I would try to pick examples which is as extreme or as wide as possible. And last thing would about be about the job prospects, and I would talk about different scenarios and the different job positions that is available in today's industry, and how I personally got into this space of IoT, how people would anybody who's interested in starting to IoT can look into it. So I'm assuming all of you or most of you from the engineering background are still students working in or studying different engineering domains. So I assume you all would be make a very proper audience for us to begin with. So so what is IoT is it's a very definitive question. So internet has changed a lot in the last few years. So if you look at the history, internet has been around since the 1970s. So it has always been for the people and by the people. So for the last from the 70s to the 2000s, so people were using internet for the email, news, chats, and lots of things. So it was just about people, and it was created only by the people, and things started to change, and it's not just only about people anymore. So if you go back to the definition, if you ask me what would be the right definition, I would probably say anything that is connected to the internet and that can talk to each other could call be an internet of things. So we would call this thing as an object. So an object could not necessarily be a physical device. It could be a software component, it could be a hardware component, or it could be a software component. So it could be a simple sensor, it could be a smartphone, it could be wearable, it could literally be anything. Yeah. So what happened? How it started was, this started in the year 1999. So this was probably around uh, 20 years ago. Yeah. So this was started in the term of RFID. So what happened is during in the 1999, the people in the American companies were using RFID, and this was the first time the term Internet of Things was coined, and this RFID was used as a very important component for supply chain. So any goods that's coming into the factories or the industries would need to be scanned, and there was lots of production happening, and in order to keep this raw materials in stock, they were using RFID. So each of the stock would have an RFID tag, so you could scan it, so you would know which raw materials has arrived, which has been used, which has been returned. So this was making a supply chain a lot more easier. So that's when the term IoT has evolved. It's purely started with the RFID. So you would have known RFID is something like a smart card we have in our ID cards. So when we have to go into our office premises or library, we would just tap into the office and we go in. So that's basically RFID, and that's when this IoT started. But then around the year 2014, that's when the things started to become more popular, and more industries have started to use the term in a commercial space. Now you would see any company would try to say we are doing IoT, we are doing that, we are doing an IoT product, and anything they're making, they would just add a tag name called IoT. So as an engineer or as a commercially aware person, so we should be around the year 2014 is when things started to happen, and more popular companies are starting. So what we have to understand is that not all companies are doing IoT. Mostly it's just a gimmick. So you could probably do anything and still call an IoT, and we should be able to understand what really is IoT and what separates from things that's not an IoT. And even if you take a smartphone, so how many sensors do you think our smartphone could probably have, if anybody could make guesses? So that's at least 14 sensors we have in our phone sensors. That's probably due to the advanced technology like MEMS. So MEMS is nothing but the micro electromechanical sensors. So those things could happen. So if you ask me if this is the definition of IoT, then it's not. I could say yes and no, because this is also a definition of IoT, but this is not the only definition of IoT. And there is no single definition of IoT. And if you ask any person what is the definition of IoT, it could change from person to person, industry to industry, and technology to technology. So any person working in different industry could define their IoT in their own words and in their own technology. This is probably because IoT itself is a very high level concept. So if you wanted to break IoT into its separate parts, you could break down into hardware development, data analytics, cloud, DevOps, and there's other management things going on. So there's like plenty of things that comes under IoT, and there's a lot of keywords. So you could there are many keywords like IoT nodes. You could call sensor nodes, something called fog computing, edge computing. There's like different keywords. If anybody wants to know more about these keywords, you could probably go and discuss in the Cisco's definition. So they are the ones who have been defining the keywords and the standards, especially in the space of IoT. And another one thing is that IoT is still evolving. So 4 years ago, what IoT meant may not be the same. And so the protocols are changing, the protocols are evolving. So it's always growing. So if I'm someone who can define an IoT protocol right now, 2 years later, it would not be the same because the technology has evolved. So we have to be constantly aware of what's evolving, and we should be able to update it. And another thing is that there are many business and stakeholders involved in IoT, and there is a huge number of software companies doing their own IoT things, and a huge number of hardware company doing their own IoT things. And there is like big players like Azure, AWS. Azure is the Microsoft product, so they would have their own cloud enterprises supporting the IoT. So these things could mean different things. So there is no fixed definition, and you could make definition from your understanding, but what we have to understand that it may not be the same for everybody. And yeah, so that's the reason, and that's the reason why we do not have one single definition of IoT. And also, so one thing we have to understand that most IoT systems, or every IoT system, is generating a huge amount of data, and and how to store them and how to use them is another big problem, and which we are not going to discuss now. But what we have to understand is that IoT is constantly evolving. Like I mentioned in the 1999, how it started with RFID, and now and then later in the 2000, the technology has become to Bluetooth, and now it's NFC, and those things tend to happen. And even healthcare, you can see now IoT starting to come in, and then there is like more emphasis on data privacy, and you can see more and more your home automation products coming in, and there's more cloud analytics, DevOps, so those things coming in. So this is all is constantly evolving. But one common thing that is happening is that generation of data. No matter which layer of IoT you're in, one common thing you'll notice is that there's always a huge amount of data that is being generated. And as you can see, these are the aims of the uh, IoT. So when I say global identification of things, it means that each object that is in an IoT ecosystem will have a address. If I were to connect probably say 100,000 sensor, so I want my each of my sensor to have an even identity. So I can address my sensor, and I can know which of my data belongs to which of my sensor. So for example, if you wanted to do an automatic light control in a shopping mall, so you wanted to know the address or a tag. Address is probably like an identity tag to know it. And yeah, so another characteristic is to sense the physical environment uh, and while reacting. So not all IoT devices are just sensing. Some devices may sense, some devices may react, some devices may do both. So these things are possible. And third quality is called autonomous. So it means that once you deploy a IoT device, so you want it to be autonomous, it should be able to function on its own. It should be able to turn on, turn off. It should be able to take care of its own battery. So these are the things. And another thing is called anytime, anywhere, anything connectivity. So probably you wanted to connect anything, anywhere. In some cases, you might want to connect an sensor that is like a good 300, 400 feet underneath the ground in a mining field. And sometimes you wanted to connect a sensor to a, a luggage that's like that's being shipped from one country to another. So basically you want an IoT object to be identified no matter where they are, when they are, and yeah, it could be anywhere. And another aim is to have an interoperable standard networks. So this is a quite interesting one, because now we have a different vendors. We do not have a standard in IoT. For example, you would see um, Google Home, Alexa, this kind of products. But you should also see our home automation products like a smart bulbs and other things. So these things have to be interoperable with each other. So if you and me were to create a new IoT product, and so we wanted to make sure it can connect and talk to an existing ecosystem. So if I have my nice home automation network, the next time I bring in a new IoT product, it should automatically connect to my network without much of a fuss. Uh, this is another important feature. And another feature is the light and low resource devices. So you want a sensor which is very small and very uh, very resource constraining. So if you see, most of the sensors, IoT sensors, would probably be running on a battery. So if you take it sensor that is running on a Bluetooth, and if you put in a coin battery, it could has a lifetime up to from 2 to 3 years. So probably a sensor could have a lifetime of 3 years just by running on a battery. And not necessarily the sensor has to send in a data every 5 seconds or every 10 seconds. Sometimes it could be 1 or 2 data points per day. So it totally depends on the application. And another thing is that sometimes it is easier to deploy a new one rather than changing the battery. For example, if you deploy a sensor like 400 feet under a mining station, you don't want to go down and change the battery of the sensors. You might as well buy a new one and put it there. So this is another thing. Another feature is called the machine to machine interaction. And so yeah, you can see devices are talking to each other. That's another improbable thing. And we also have something called the semantic web interoperability. So semantic web is a it's quite new term. So it probably means the ability of machines to understand data. And most of you would have had a little bit of experience with web development. So if you develop a web page, you want the web page to look the same in your phone, you want it to look the same in your desktop and in your iPad and all sorts of the things. So this is called semantic web. So it's basically the definition would be extension of web to make the data more meaningful. A data could be reused in multiple applications. So if I wanted to create an web page, I wanted to create it in such a way it is viewable properly in my mobile phone, laptop, and across all devices. This is called semantic web. And another interesting example is like the first time uh, semantic web introduced was in this 2010 FIFA World Cup. So that's when they created a website for FIFA World Cup, and that was viewed across different countries, different browsers from different platforms. So it was viewed from devices that was made in 1990s. They not time they had futuristic iPhones. Um, so yeah, it should be made in a way where it works in all the previous devices and in the future devices. That is semantic web. And another huge domain in IoT is the big data acquisition and analytics. So you would have seen lots of courses and lot of big data first going about. So it's about handling huge amount of data and how to make sense and how to find insights from this large amount of data. That's itself a separate section. And the last thing is something called anything, anybody, any place can innovate. And so sometimes you wanted to decide where an IoT device would be. For example, if it's inside a house, uh, so most probable mode of communication would be Bluetooth because it's inside a house, whereas the GPS wouldn't work if you are in a 5-floor building. For example, if you're in the first floor and if you move to a second floor, the GPS wouldn't know because it just works with the latitude and longitude and not with the height. And sometimes if you are in a forest, you have some range issues. You have to be careful on what type of communications you wanted to use. And if you're in a hospital, you cannot use all sorts of frequencies because they have very critical healthcare systems which may interfere with radio waves. So you have to be careful with what frequency of radio waves you're using. And if an IoT device is on a shape which is traveling from one country to another, so you want to use some technology like Sigfox. So this is like if it's just like you just put in a SIM card in an IoT device and that's it. It no matter which country it goes, how far it goes, it could send in data. That is the that is these are the things you have to be careful about. And last point about anything, anytime, any place can innovate. So what probably happened is that for somebody who's building an IoT product, we don't necessarily have to create something from scratch. So we have an existing number of nicely built hardware platforms and cloud platforms. You can see, you would have seen in Azure, Microsoft, they are all doing the cloud platforms. So if I want to build a business, I would either build a device and use the existing cloud platform, or I could, and because it's just a lot of time, it makes no point for me to build something from scratch from absolutely zero. And even to build an hardware, it's quite extensive task. So you might want it to use an existing hardware platform and just build an application out of it. Yeah. So this is the vision is not one thing that might be misunderstood is that the vision is most oftenly not to connect everything, and it should make sense to what we are trying to connect. Just because we can connect everything, there's no point in connecting everything. We should be able to understand why it is needed and how it can help the society or how it can transform the basis. And I found another example here for the vision. So this you could see from the slide. This is supposed to be a smart water, and that probably tells you and reminds you to drink water, and it can connect to your phone and your smartwatch and those kind of things, which is really absurd for me. So as long as you were able to make something out of it and make money off it, it's fine. But thing is, of course, you can connect anything and everything, and decision should be come to what you want to really do about it. And yeah, so if you look around us, if you just look around in your office situation or in your college situation, so you'll see lots and lots of automation that is happening. You will see the automated coffee machines, and you will see lots of and enterprises deploying their IoT systems, and now you have been using your mobile phones for all sorts of payments, and you have your smartwatches. So if it all says that number of connected devices is increasing, and the human to human interaction is actually decreasing. And you could see, I can see in my slide, these are the different trends that's increasing. You will see a increasing number of machine to machine interaction. That's what we call an M2M. So this is most common in industries where if you have a lathe machine, different types of lathe machines, you wanted to record the data, and this data is indeed used by another machine, and it will automatically adjust its calibration, uh, or the settings based on devices from the other things. So these are the current trends that's happening. And another thing is that about by 2025, it's estimated that there are about 41.6 billion IoT devices. You could see how much of each devices can generate data, and what there's plenty of opportunities for everybody to make use of the data, and this data engineers, data science people, how they wanted to make use of this data. Yes. And talking about the trends in IoT, so these are probably the most common keywords you've been associated every time you talk about IoT. So data analytics is in itself is a huge domain, and you would have seen so popular people taking up data science courses, data scientists, data engineering, all those things comes under the data analytics part. And so this involves different tools like Grafana and one-click solution. These are the dashboards you wanted to talk about it. And when it comes to home automation, you have seen Xiaomi or those kind of companies selling the smart light bulbs and voice assistants for a price as low as 1,000 rupees or something. But what really happens is that actual cost of making the device would probably be just 100 rupees. Uh, and but then they are selling for 1,000 rupees, so that is the amount of profit they are making. And IoT security is another huge topic, and that's a blind spot. For example, despite lots of efforts from the governments and the companies to strengthen IoT regulations, but it's not happening. And you would see, since more and more IoT devices are being coming into the system, you'll probably find more and more security breaches coming in, lots and more cyber attacks coming in, and hackers will try to find more vulnerabilities in the system and try to exploit them. And this is probably because there is no IoT security standards that's been put, and there's no regulation that tests the quality of IoT security in such devices. And those things are possible, but it's happening, and a lot of regulations are still making in the locking in the place. And especially in a country like India, if I were to predict, if somebody starts up a company that just do the testing of IoT devices, they would make a huge amount of profit. There's plenty of scope for somebody who's starting an IoT security company in a market like this. And another huge area is the smart cities. So I think we would have heard a few years ago about India, making a promise of 100 over cities, 100 smart cities. So if you take India, uh, among all the smart cities, Bhubaneswar and Pune is probably the best smart city, for example. And so smart city is nothing but it's a concept where you wanted to have a single platform to monitor performance and decision making. For example, if you're having a transport system of buses, so what you really wanted to do is put a bunch of sensors in the buses that would probably tell when the bus is arriving in a bus stop or how many people are getting on board. So this gives in the government more information about what are the peak times that the passengers are using. Say, for example, if the peak time is between 4 p.m. and 6 p.m., the government can identify the pattern. They can identify the stops where there are more people are getting onto the bus. They can understand more about the data. They can deploy more buses in that particular busy route. So these are the things that can happen in a smart city. So this is the reason why they wanted to have a single platform to monitor performance and then make a nice decision about it. And yeah, so bus traffic is in, and we previously spoke about energy and resource management of IoT devices and those things. So healthcare is in another way, and but in really advanced countries like Norway and those countries, they are even using the smart patient monitoring system for the COVID-19 patients. So it could have been possible, but what's the problem is that now it's too late for them to test the systems and deploy it to the patients because they don't have the time, they don't have the space to test those systems and deploy it. Had we had a nice remote patient monitoring system already existing in our hospitals, so we could have easily been able to handle the COVID situation better. So right now, more hospitals would have realized the importance of IoT in healthcare, and they would be switching to IoT based patient healthcare in the future. And another topic is the predictive maintenance. So I have a case study mentioned about this predictive maintenance later on. So we could talk about this. And and also so predictive maintenance comes under industry 4.0, and we would have a little bit of case study for this. And edge computing will take a prominence over cloud computing. So right now the last 2 years we would have seen a huge increase in cloud computing. Everybody's talking about cloud computing, and trust me, in another 2 years you will hear the term called edge computing. So the difference is nothing but cloud computing, the processing is done in the cloud and the data is sent back. Sometimes the only difference is the same processing is done in the edge. When I say edge computing, it probably means you want the processing to happen within your premises. That's the only difference. Otherwise, the technology is the same. But you will see more and more people talking about edge computing in the future, and yeah, it's going to happen. And this is just the pros in the IoT society. So we have seen more automation coming in place, which means that less physical and mental human overload. So we'll have quicker access to services driven from the physical interfaces. For example, if you have the automatic doors, automatic lights, so all these things would automatically change the reactions to the environment. And efficient than an uh, this is more efficient than a human operation. That's the case I wanted to reply. And talking about the classification of IoT domains. So we started the IoT in a supply chain. So if you could see, logistics is pretty much the supply chain. So we started the RFID with the supply chain, and and then we have moved to environmental sensing, healthcare, home building, retail, those kind of things. If I just take retail, I could spot like 25 different use cases just in retail. So that would involve inventory management. So I think you would have seen a few months ago there would have been a nice Amazon video where people would go into the supermarket, they would just pick things, and as soon as they come out of the shop, they would automatically kind of getting paid. So that's called the Amazon Go. Those kind of IoT use cases comes under retail, and personal notifications. Every time we purchase something, so we get notifications, and like in how in Uber Eats or Swiggy we order food, and we get a specialized discount exclusively for that particular user. Uh, it's not for the entire one. So this is because our data is also being constantly monitored, and we get personalized notifications. Could also be a use case of thing. And energy is a huge $1 trillion economy that's contributing to the IoT. So you would have seen one use case I could think of is that in Tamil Nadu recently last year they have ordered an issue of replacing the existing energy meter, the traditional energy meter. So what happens is that in traditional energy meter, a person from the electricity board would come to house every month, would take a reading, and he would go back to the office, give you the electricity bill, and they wanted to replace it with a smart energy meter. So what smart energy meter would do is just straight away send the send the data of your electricity usage directly to the server, and it is calculated automatically. So if you could see, almost entire households needs to be replaced by this energy meter. So a smart energy meter would probably cost around 3,000 rupees. Right now they don't have sufficient suppliers to do it. So a private company who's taking up orders or taking up orders from my electricity board in order to make energy meters would be a huge profit. And anybody can make this smart energy meter, but only thing you have to know is what data format you're sending to and what IP address, or the IP address of the server, because that's a destination which you're wanting to sending it to, and then it should be fine. So this is another huge area that is development for IoT. And in manufacturing we would have different things for our industry 4.0, and transport, which I said again it comes under the smart city. So this is the different types of classification of domain. And going back to state of art, one thing that we have to be careful about is the large scale nature of IoT. So when I say large scale, the scalability doesn't apply necessarily to just the software, but also to hardware. And I don't know how many of you would have worked with the Arduino and other few microcontrollers as a part of your university projects. So what we have to understand is that Arduino is not a scalable hardware. You cannot never build a real product of an Arduino. It's just a prototype. You can use it to have an showcase an idea, but you'll never able to make it a product. And when I say scalable, if you have an idea, if you were able to demonstrate that idea over a Arduino, and if I were to ask you to make thousands of such devices, you should be able to do it. And that's what I mean by scalable. So you have to be keep these things in mind if you wanted to make an IoT device. And second thing would be an intelligence. So this shows how smart a device can be. Some devices can change the sense in data, and they could just turn them on, turn it on, turn it off. And yeah, and based on sensing, it could be a different thing. It could be how often do you want it to sense the data. So it, of course, IoT cannot be realized without sensors. So it's about how we wanted to reflect the changes that's happening in one environment. So it could be the technologies that provide capabilities to reflect the awareness of human and physical world. So it doesn't necessarily to be analog, it could be digital as well. And it totally depends upon the application. Some sensors just measure what's happening in the environment and they react. Some sensor would just measure it and not react. And there are different types of sensors which you do not want it to get back. Another thing is called the dynamic environment. So if you wanted to create an IoT device, it should automatically able to join the network, leave the network without uh, without disturbing the network. For example, if I wanted to bring in a new device into my house, I expect the device to connect to the Wi-Fi automatically, and I do not want to restart my router every time I wanted to bring in a device. So these kind of things has to happen. It should smoothly get onto the network and smoothly leave the network when its lifetime or application cycle is over. These are the four things. And another things would be the massive amount of data. So as we predicted, there are like 40, almost 40 billion devices happening. And if you imagine uh, each devices produce a data each day, so that's like 40 billion data points we have in a single day. And that's necessarily not the case. Sometimes sensor may send the data every second or every minute. So the scale of data that is being expanded is huge. Uh, and sixth is called the heterogeneity. and which we have discussed before, since there are multiple IoT devices and manufacturers coming into the picture, they should be able to operate with each other without any problems. And another thing is called the limited energy. So we've been talking about IoT devices that can run on battery for years, and huge thing is happening. And replacing battery is often costly, so you would rather buy a new device. That's the most important thing. Like, it's similar to a mobile phone where you break your screen, and replacing the screen would be more as expensive as buying a new phone. You might as well buy a new phone. So it's a similar thing. And when it comes to connectivity, you could talk about different things like Bluetooth, Zigbee, Wi-Fi, LoRa. Plenty of things happening. We will cover that in a slide that'll be coming on later. So um, these technologies are chosen according to the application, but one common thing is the same. They would just send the data. That's a common thing across all communication. And last thing about cell configuration is to how many devices to work together to provide a certain functionality. So sometimes the device would need to automatically calibrate over a period of time. And you don't, once you deploy it, you don't want people to come and interfere with it quite often. You just want it to leave it as it is. And yes, as you could see, this is the leading companies. I may not have put all the companies that is available here, and some of you have been familiar with it. And uh, yeah, Cisco is a huge. Cisco and Gartner are probably the biggest in the lot when it comes to IoT. We may not have heard them, but almost every IoT device has to be certified by Cisco, and they are doing a huge number of network transitions and network related things when it comes to IoT. And Gartner is another huge company doing in IoT, and they're doing all sorts of products. And one interesting thing I would like to mention is about this company called Renesas. So recently, we've been working with my company has been working with this Renesas company, and they have created a device which is completely batteryless. So what it would do is it doesn't have a solar panel, but it would just take the temperature difference between the air and the ground, and it would generate energy from it. So it would probably generate a voltage of 2.5 or something, and charge a small capacitor. And the battery, there's no battery, it's just a capacitor. We call it a supercapacitor. So it could charge quickly and it could discharge very quickly. So we have a very power efficient microcontroller which can take advantages of this supercapacitor and takes this 2.5 voltage and sends a quick sensor data on a Bluetooth, and then it goes back to sleep. So these kind of devices, once deployed, can go about a lifetime without battery for years. You don't have to replace at all. So you can see more and more devices coming in the future. So Genesis, it's not Genesis, everybody is doing it, but I've personally been working with that particular product from Renesas, and they're doing really well. And Rockwell Automation, I've created a case study that we might discuss later. And quite a few of you would have been familiar with a company called General Electric. So we all know General Electric has been a prominent leader in making industry equipments, switches, PCBs, and all sorts of mostly industrial equipments. But what you have to do is that now they have the 70% of the workforce is probably working in industrial IoT. So it's completely based on data analytics, and their main business right now is to provide IoT insights, uh, IoT insights generated from an IoT systems. So General Electric has been around for good so many years, and now they are also moving towards IoT, and they're moving towards IoT analytics, which is this thing. So we often call this industries core industries because they do the core thing like electrical or electronic or some sorts of triple E, those kind of stuff. But that's not the case anymore. as you could see, they are transforming, and they are requiring more and more data engineers, cloud engineers, and there's a massive difference but it makes a massive difference if you're from a core background, and you're able to do more than core, and they want somebody who has understanding of core industries, but they wanted to make more out of it, like more data analytics, cloud, IoT, those kind of things. So that's a thing. And you can also have IBM. So IBM is doing if you just type in IBM IoT, you could see they have the huge tutorial about how to test their IoT systems with Raspberry Pi or Arduino, those kind of things. So yeah, you can see IBM and all these companies are slowly realizing the potential of IoT, and they're moving towards it. Some of them have already started it, and you can see Grundfos also doing pretty much similar thing. Another interesting thing is the Vodafone, and we all know Vodafone is something, they sell the mobile telephony, mobile communications, but 30% of their income every quarter comes just by selling IoT solutions. And in fact, they would be moving more towards IoT solutions uh, happening. Okay. So this is so we've all been familiar with the IoT system in general for now. So you would have also been seeing about OSI layer. So you would have studied about the OSI layer, about network and those things. And similarly, we have a layer for IoT as well. And you can see first layer being the physical layer, connectivity, edge computing, data accumulation, data abstraction, application, collaboration, and process. So you will have all the embedded engineering, all those things in the edge layer, and you will have the communications like LoRa, Sigfox, those things happening here. And you will have edge computing, the gateways coming into here, and you will have the databases, different types of databases storing the data would happen. And in this here, this is where the data analytics parts coming in. So you'll have the machine learning algorithms, data mining, those kind of people working in here. And then there's application where you have dashboards. Say, for example, if you're using your your bank or say Paytm, and it would use a nice data abstraction, and it will present you your monthly expenses in a chart. So that's probably the application. And then this is called the collaboration processes, where you make decisions out of the data. So that's how an entire IoT devices would work. And another example I would like to talk about is about the retail industry in America. So what they interestingly found was that in a particular supermarket, something like a Walmart, and they found that the beer and the diapers sales were unusually high, and so it was quite surprising, because the diapers is for the baby and the beer is for the grown-up adults. And how come these two have such a correlation of high sales? And after analyzing the data, and you could see from the graphs, the beer and diaper were brought at the same time in the same bill, and which was quite confusing. So what really insight said that a young father on a Friday afternoon, so when he would go to the supermarket to buy a diaper, and because he would have to spend the rest of his weekend at home, where he would not be able to go out with his friends and those things, and so he would probably buy a crate of beer for himself to keep him company. So what the higher management decisions in the collaboration processes did is to move the beer next to the diaper, and they could see the sales going even up higher. So this is how data and could be used in order to improve your business. And this is a quick workflow of IoT system. So, and people, you have seen about the device driver. So this is where the hardware device would talk to the sensors, and edge software is something like a gateway. So all the devices in the home network would send in the data to the gateway. Gateway would do a little bit of fog computing, and it will store the data locally, and as and when requested by the data collection or the database, it would send in the data. And you can see the relational data. Not necessarily we use relational data, It could be non-relational database as well, and it could further be extended to application and analytics. When it comes to again driver software, it depends. It comes down to whether we're using an program or an auto software. So people who are working in embedded domain would understand. And few popular IoT databases are probably MongoDB, InfluxDB, those kind of things. And this not necessarily have to be a two-way. Sometimes the device would just send in the data, and sometimes the IoT layer at the top might request data. So it did not necessarily two-way. It could be single way as well, depending upon the thing. So now I've put in the previous two pictures in the same thing. Um, so you can see how each of these corresponds to the layer. And yeah, so one person cannot necessarily master all these components, and we cannot expertise everything, but one has to understand the flow. Say somebody, if you're a data engineer, you must know what is the layer below you and what is the layer above you. And if you're an embedded engineer, you might know what's the connectivity you're using it. And if you're a gateway engineer, someone who's a software developer, you wanted to know a layer above you, below you. So you don't necessarily have to understand the entire workflow, uh, or express in all fields, but you have to understand how the data flows. So for example, companies like Accenture would just work on collaboration applications of analytics. That's it. You wouldn't see them making physical devices or protocols. Whereas some companies like even Zoho has their own IoT devices just for the energy, but they wouldn't make any physical devices. They would just buy it from some other company. They would just do the cloud, analytics, these three parts. That's it. And let's moving on to the software development. Even if you say software development, there are three types of software teams working parallelly. One is this embedded set of embedded engineers working for the connected cars, appliances, and then you have the big data engineers. So if you say big data, they would be probably using tools like Apache, those kind of things. And the embedded engineers would be working on Wi-Fi, low power energy, those kind of things. And then there's mobile application team. So they would be doing the front end, like the web pages, dashboards in for the data to show a nicely presented. So most of them are application developers. So one necessarily have to create an hardware device from scratch, but you have to develop your application on top of it. But you need to have the understanding of sub layers. Uh, Not all companies may not do all three. Some may do just one. Some may do this and this. Uh, and yeah, and if you could see how this each layer is connected, it's by the APIs, and each of them use APIs to exchange of data or exchange of functions. So it would be very good in fact if all of you familiarize yourself with API, how to use API and how API works, how to create your own API. It would help irrespective of you, whether you're an embedded engineer, big data, or a mobile developer. So understanding API is very, very important, and all the UI UX developer could also come in under the mobile application team as well. And this is the protocol I was talking about. We were discussing different protocols. If you could see, all of them does one simple thing is to send data, but that the only difference is in the frequency of the range and the data rate. For example, if you wanted to send your IoT device to take a picture and send you, then you probably want 2G and 3G. But if you wanted to just send in sensor data, you would need Sigfox, and how fast you wanted to send it, and the power usage, cost. So you would depends upon your application and your requirement. So you would choose the right communication. Uh, and then we have something called hardware development. The biggest challenge in IoT hardware development is called scaling. As I said, Arduino board may be good for an hobby electronics, but it can never be made into a product. And that's the biggest challenge for startup. Even if you wanted to make a simple automatic light turn on and turn off based upon proximity detection, it might just take an hour and just take 60 minutes to build a prototype. But to make a product, it might take 6 months. So that's the main reason why most of the companies uh, are concentrating on software development. So what would make sense is to probably buy an already existing well-established hardware platform so that you can build your application. So that's what is happening. designing a hardware from the scratch would take a long time, but then it's not advisable to do so. If you wanted to have your own startup, this is what it makes sense. And somebody who knows software and hardware is what we call as a full stack developer. It's different from full stack developer. So we refer a full stack developer is usually someone who does an web development end to end. A fuller stack someone is basically a hardware engineer who could do just more than hardware. That's one more thing I wanted to see. So yeah, the communication channels, it would be the Raspberry Pi. So if this is a Raspberry Pi, it would be a Wi-Fi, a UART, or a LoRa, those kind of things, and whatever sensor you wanted to use. And the cloud service could be an Amazon or an Azure or a different provider, and the end user is the customer. So that's how the data flows if you wanted to create a project. Yeah, and going back to the job level, so you cannot just start with a IoT engineer. If you take an IoT engineer, underneath they're probably an embedded engineer or a software engineer. So if you wanted to start with something, uh, you have to start with a data engineer, junior software engineer, or embedded engineer. So this is how you start with, and that's how you work your way towards it. So when I started, I was working as an embedded engineering intern, and then you understand the system, and then now what I wanted to do is more about cloud. Now I wanted to study and work more about how to connect your hardware onto the cloud, which is a very interesting area. So these are the entry path to work with. And sorry, uh, again, this all would be for the senior level, somebody who's already working as a cloud engineer, integration engineer. If they go to an IoT company, they would still do the same thing, but their approach would be different because they would have to understand where the data is coming from and how the data is going out. As I mentioned, a fuller stack developer is somebody is a hardware engineer who could do more than hardware, and so you need these sorts of engineers in order to run a complete IoT system. And one interesting position is called the solutions engineer. So he would probably convert an idea into a design and then to a code, which is quite interesting. Yeah, and this is probably a top roles in the top management. So this would be an IoT business director. So all these people would have started or would have had years of experience as an embedded engineer, software engineer, cloud engineer, and just because they're able to understand the flow of data or the flow of software right from zero to the highest level, they're able to make decisions. And in order to be here, you have to have a bit of experience in cloud. You don't necessarily have to expertise it, but you might have to understand how it might impact the other lines of business, which is very very critical. And system designer, you have to create a system where you wanted to survey, you have to research what would be the right tools and technologies in order to suit the requirements, and then you would tell each of your engineers what they need to do. So you would organize what each embedded designer does, what your app developer does, what your database developer does. So system design engineer would probably control all these things, and tell the engineer what to do and what not to do. And I've told you mentioned earlier about the solutions engineer, and the product manager is someone who tries to understand the requirements of the product. So he would be interacting with the client, and the client would want a new feature of the IoT device. Say for example, they would have a product that sends through Wi-Fi, and then the client would come and say, instead of sending on a Wi-Fi, could you send it on a Bluetooth as well? So he has to understand that uh, in this case, the application engineers, other layers would not change. The most underlying change, the connectivity layer, might only change. So the product manager would just go talk to the embedded engineer, understand what changes it has to do just to change between from between Bluetooth and Wi-Fi. Yeah. Going back to the case study. So I earlier mentioned about Rockwell That's another company who's doing a lot of things. So Rockwell themselves do not have a own cloud platform. They are completely rely on Microsoft. So we know the two big giants are Azure and Microsoft for cloud platforms, and there's no now they're pretty much like a monopoly. We do not have a choice, but we have to either use Microsoft or Azure, and the next big thing is the Google or the IBM. So either way, you have to use one of their cloud products, and because it's very difficult and expensive to create your own cloud platform in order to support your IoT. So you might want to put your IoT on an existing well-established IoT product. So there's an interesting product called Azure IoT. So what they have is they have a very pre-configured IoT machine learning models, and because in order to build a nice cloud platform, you have to hire a huge number of cloud engineers, network engineers, data scientists, and it's really expensive to hire a data scientist. So somebody who has a bit of IoT experience can do all sorts of things. If they know how to use Microsoft Azure IoT, they can pretty much do the job of all these engineers. So what this case study is about, because they're using real-time analytics, so they are using lots and lots of data coming in from industries such as oil and gas, and they would predict when this equipment would fail. Along with the supply chain, they track the performance in real time, and they might help redefine their equipment designs and process. So Rockwell has been able to do this and increase their efficiency. They are completely dependent on Microsoft Azure. So you can see this is the case study, and you can the devices and gateways where this is the data coming in from different types of walls, different types of temperatures from a gas mining industry, and this is probably they have their gateway as well. So it goes to Azure, and whatever machine learning models they have already well-defined pre-trained machine learning models, so you don't need anything to do. All you know to know is how to use the APIs in order to use this feature. They also have a well-established database, have the well-established dashboard, well-established storage analytics for the big data. So as an IoT engineer, who all you have to do is how to understand you have to understand how the data flows from the devices and gateways and to each of these particular components. So all you need to do is how to use the APIs. So if I have a machine learning API, I need to know how to use this API. So you could pretty much achieve the predictive analysis just by knowing how to use Azure IoT. So that's another thing. Uh, and these are the tools. Power BI is a very important tool just for visualization. So somebody who knows just Power BI itself has a very good scope. If you're right now, any of you decide, I just want to learn Power BI and I wanted to learn Power BI engineer, because there's plenty to learn in just Power BI, and you can actually make a very good future just out of Power BI, because knowing the tool itself takes a good few years, and knowing that really well can help you go a long way. And like that, we have other tools like Azure Functions, Data Lake, Cosmos. These are the tools to do it. Yeah. And another case study is with the banks. So most of the banks, you can see more banks coming in. Most of them are online based models. So they do not really exist in physical branches anymore, and they are heavily dependent on cloud. So and now there are few banks. What they do is they do sell their smartwatches to the customer, and on an EMI, and their interest rate is dependent upon how well you use the smart device. Say for example, somebody buying an Apple Watch on EMI. So what it really does is how well you use the Apple Watch. So if you're somebody who's going for a run, somebody who goes working out, so this data is collected by the bank, and they are offering an extra discount in the EMI percentage for somebody who's working out, who's really staying fit. So these are so I mean so this is not a really great case study, but this probably tells you the possibilities of using an IoT to improve your businesses. So another important thing they would do is about the car insurance. So a sensor or a device installed in your car would constantly send data about your driving, about your accidents, how often you go over speed, your GPS, and those kind of things. So in case of an accident or in case of an insurance reclaim, the the banks can probably charge you based upon your data. So somebody, if you have a very clean record of a very clean driving experience, so you would be charged less of an insurance premium based upon your data that you have been gathering for the last few years. So these are the other applications that's been happening for this US bank. And another one I'm going to talk about is the John Deere. So they have done something called the platform as a service. So you would have all heard of different types of service like infrastructure as a service, platform as a service, those kind of things. So they have a nice agricultural platform. So what they do is they collect data from different crops and compare the data from the previous years, and they give insights back to the farmers about how well the crop is doing compared to the other farmers. So this could also involve asset tracking and management. And so we call this insights as agronomic optimization. So even in India, there's in Punjab, there's a company called AG Next, which is a startup doing similar kind of a thing. And there is another startup in Gurgaon called Evergreen Bots. So they're not the industry leaders, but they're definitely making huge amount of money from whatever clients they have. But then you can see them more and more startups coming in and picking up from here. And going back to how to get into the IoT domain is probably you can choose three pathways and switch between these two. So once you master any of these two, you'll probably become a move into more higher level management. So you can, based upon your skills, based upon your interest, somebody who's interested in data, you could start with data engineering, or somebody who has from electronic background could start with embedded, or somebody who's from a computer science background can start with the software systems just by learning about cloud web development. So you would cross path with data engineering or embedded. You would cross other parts as well. As an IoT engineer, you are expected to learn more than what your core skills are. Um, and somebody who's one, like I said, Power BI itself is a huge tool, and it will take years to understand and master. That That's another interesting thing. These are the skills that you would like to, if you wanted to become into the IoT domain, any of these skills and expertising in any of these skills would probably help you. Node.js it's very great for somebody who's working on a cloud-based system. Lots of scripts are written in Node.js. Lots of server automation scripts are written in JS. Those things could be quite handy as well. And when you're trying to learn about database, try to learn about more modern database. SQL is not the only database. As you know, there are plenty of new modern database that's coming. Try to learn them, and all of them are open source. And you all have a free account in Azure and AWS. You could just log in and practice these tools. And when it comes to cloud containers, cloud skills, this is where DevOps comes. DevOps is, again, you could talk about DevOps engineer. If somebody who knows very well in maintaining containers, maintaining Kubernetes, those kind of tools, it would again be helpful. So you would probably, as a DevOps engineer, you would probably be helping the other software engineers and to maintain the infrastructure of the IoT. Those things can be happen. Uh, yeah. So all somebody who's already know these skills. So you might already be working in a DevOps engineer, but in order to get into the IoT, you should probably know how to interface such tools within an IoT ecosystem. That's one thing you might wanted to learn if you wanted to switch. And yeah, and so somebody as a freshers who wanted to start, I would not suggest Arduino. Arduino is good enough for understanding, but if you wanted to get really industry standards, that's not a good thing. You might as well start with Raspberry Pi, which is better. You might have plenty of projects, and the first project anybody would try to work on would be the visualization project. So it would just be monitoring or sensor data in real time. uh, that would be the most ideal project for anybody to start with. And when I say gain a deep understanding of sensors, it doesn't necessarily have to know how a sensor works, what technology it is made. No, it's just about what the data tells you. If temperature says some value, all you have to know that how to make sense out of the sensor value, how to use that sensor value in your application. That's one thing you would expect to know. You don't necessarily have to know how the sensor is manufactured, those kind of things. What you expect to know is how to make use of the sensor. For example, a temperature a sensor would tell you about humidity and those kind of things. But using the humidity, you can do plenty of other things. Using humidity values from humidity sensor, values from a carbon dioxide sensor, you could probably detect a pollution. You can calculate pollution levels based on different sensors. So that's the intelligence one might want. That's what I mean when I say you have to understand how understanding a sensor means. And programming language, mostly it's Python. Whatever components I've mentioned, it could so far you could get away just with Python, but JavaScript is also it's a very important thing, especially somebody who wants us to work more on the software side, something like with the containers and those things. Then JavaScript would be a right thing to you. But yeah, if you don't just know Python, you pretty much could do all the things that I mentioned before. And for somebody who was already experienced, or somebody who's been working a little bit into the field, like I said, IoT itself is not just one skill, and you have to go behind your core skill. And even with personally, when I started, I would just know embedded systems, and you have to go beyond a little bit more about app development, more about cloud dashboards, those kind of things. And one another good approach would be to understand everything from the perspective of data. If you see data coming in right from the point it's generated from the sensor and right till the point where it's made sense, that is the dashboard. So you have to understand where this data is generated from, where it is going, how it is being modified. So this itself would give you and eliminate a lot of scope in terms of debugging and problems, which is yeah. So all you have to think is just from the perspective of a data. If you understand how the data influences your organization, influences the layer before you, the layer above you, yeah, that would be good for going in. And yeah, everybody should learn cloud and data. It's like how a few years back how you would put, I know, MS Word operating system as in every resume. So right, like that, cloud and data engineering is equivalent to that. Everybody should know a bit understanding about cloud and data. So that is expected.